Hello, my name is Zorz. I come from Slovenia. I represent here the Go6 Institute and the whole platform that we managed to put together. And today, as a closing session, I will show you some mobile broadband IPv6 deployment, how it works. We have deployed IPv6 in 3 mobile networks in Slovenia, and it's in production state. So now I don't have a pointer, so I will have to do it from here. So about me, in a glance, I'm a founder and CEO of Slovenian Go6 Institute. I talked about that in last EuroNOC in Krakow. We're doing the IPv6 consultancy for many operators and enterprises. I've been working in internet operations for like 21 years. Started with VAX VMS back in days, and 12 years ago I touched IPv6 and been using it and developing it and using for my project since then. I'm also an active member of RIPE and IETF community. What we did was RIPE 501 document. It's a procurement document, how you actually request IPv6 when you're buying equipment. And I'm also the co-author of RFC 6346, that is A+P approach to IPv4 depletion. And I'm a frequent IPv6 flyer because I'm invited to many places around the world to talk about IPv6. So, what we did, we acted as a catalyst between these mobile operators in Slovenia to make sure they exchanged their experience and knowledge how to deploy V6. We helped them with the consultancy, and we also helped them test the whole stuff. So, first network that we deployed IPv6 was Tushmobil. They have this allocation, and these are actually pictures from the phone that I tested in the lab. Actually, these pictures were taken at my home. So what they did was they deployed IPv6 capability in their production network, so you could have IPv6 on a 3G wherever in Slovenia you were, or you are even now. So you see, I connected with the phone. I was on Edge, and when I connected to the RIPE NCC side, I had this IPv6 address. Also I connected to NDT from our NRN, and I had this IPv6 address. Then I tested the IMAP client, the email. So I got, you see from the log file from the mail server that I got this IPv6 address, and we're connecting to our go6.si site. You see there, this is March 5th. Can you guess which year? Come on. That was 2010, right? That was 2010. It was working. So wherever you went in Slovenia at that time, you could have IPv6 on your phone if you were a test user by then. So this is the network that was set up. We were testing DNS 6.4 and Net 6.4. We needed to do some APN redirect hack. Now that's not needed anymore because the NSN fixed their GGSN software. What else can I say? Actually, you will probably download these slides and have a closer look into this. And these are the versions of the software used. So if you are a mobile operator, if you run NSN, GGSN, and SGSN, if you have these versions or higher, you can just enable IPv6 on your network and be done with it. So this is the second network. This is our incumbent mobile network. It's called Mobitel. And as you see, I tested with the same phone. They decided to go a bit differently. I don't know if this is the operator decision or the vendor decision, but as you see, when you connect to Ericsson equipment, the Ericsson equipment lets the phone do the slack, so you fill the whole 64 bits in a host part. But anyhow, it works. This is the network that was used at Mobitel. It's quite complex. Probably you don't see the details. You can just download the presentation and see the details. So each terminal gets /64, as it is supposed to be. There were some problems with IPv6 PPP and the DNS. You had to manually configure the DNS on the phone, but this is now all fixed and done. This is something that is not considered yet as a problem. So the versions of the software used is SGSN Ericsson. This version, if you have this version, you're fine. And MPLS Cisco 7609 with that version of software. What is still missing? There is no wide support in mobile terminals. This is changing. This is rapidly changing. For example, this phone, this is an Android phone. This is not something that I run around. I usually run around with the prototypes, but this is not a prototype. This is a phone that I got from the shelf at Mobitel store. It's the first phone with Android 4 installed from Samsung, and it supports IPv6 on 3G by default. I just needed a few minutes to configure it, and it was done. So I'm running around in Slovenia with IPv6 on my phone. All Nokia phones supports IPv6 on the mobile part. We're waiting for Apple to move a bit in their iPhones and iPads, but slowly, the support is going better and better. And the third mobile network. So the first two were done in 2010, and now they are in production grade. Everyone that is a client or customer from these two mobile operators can have today IPv6 on their phone, period, no questions asked, right? You just send an SMS with the word IPv6 and you receive back the SMS with the instructions how to connect to their network using v6. What we did with C-Mobile, this was done last year in December. We tested the dual stack, so we set up IPv4 and IPv6 PDP connections, and they got the information that Cisco or Starent GGSN will support PDP-v4 v6 in Q1 this year. Yeah.
Because it's probably for 7600 GGSN, because Starent has v4 v6 for like a year already.
Yes, but you must distinguish between PDP-v4, PDP-v6.
v4 v6. I'm talking v4 v6.
Yes, and v4 v6.
All of them for at least several months.
Guys from C-Mobile asked.
Can show you working coughing if you want to.
Okay, good. These guys from C-Mobile asked the official support, and they said, yeah, in Q1 you will get the upgrades. But this GGSN supports two sessions together, like PDP-v4 and PDP-v6 at the same time, but not PDP-v4 v6. There's no option there. So we did some tests with Nokia USB modem, and as you see, we used APN IPv6 cmobile.si, and IP version was IPv6. When we connected, as you see, we only got IPv6 addresses, and when we tried to ping our web server, everything was working. And this is also IPv6 address from over the C-Mobile mobile network, and this is the IPv4 address of the same machine. This is NAT64 address, because they send out by default NAT64 DNS64 address as a DNS. So if you want to connect to IPv4 content, then you go over DNS64 or NAT64. What we did next, these Nokia sticks support also dual IPv4 v6 PDP contexts. So we tried. Although the Cisco said that there is no official support for that, but and what this stick did was it tried PDP with v4 v6, was refused as unknown, and then it built up two PDP contexts, one for v4 and one for v6. Technically it's the same, but you just lose the number of licenses used on GGSN. So we had two PDP contexts working in parallel. So we have IPv6 address and IPv4 address. And okay, this is the Nokia stick that is working with all this funky stuff. I think you can buy it today on open market. We got this like half a year ago as a prototypes. You see the few of them, and we were not even able to show it to anyone. But now it's this is public information and it's open, and you can buy them on open market. And this is also the test IPv6 on 3G from Android 4, from the phone that I showed you. And you just go in, you edit the access point, and you just select the APM protocol. You have v4, v6, and IPv4, v6, and you just connect. It's just that easy. There is some recommended reading, RFC 6459. It's from Jouni Korhonen and Basavarai Patil and Timo Savolainen and Gabor Baiko and all these crazy mobile guys. And it's some actually it's some help or showing the way how to actually deploy IPv6 on a mobile network. And what we are up to, what we are developing, we are developing this for over a year now, a year and a half. This is dual stack mobile IPv6. Does anyone, who of you knows how mobile IPv6 works? Mobility. Okay, so the idea here is, this is my device. This is, for example, my Nokia N900 phone. And when I'm home, I have my home address. So you can connect to my phone over IPv4, IPv6, no problem. When I go to some other network, right, I get the care of address that is specific for that network, but I still carry my home address. And I connect back to the home agent that is home. The home agent intercepts the packet that are sent to my home address, sends them over the tunnel to my phone, and what happens then? I start communicating with this guy, and this guy even don't know that he's talking to me somewhere else in the world, because I have the same IP address all the time. It doesn't matter to which network I'm connected. I can be on 3G, I can be on wireless, I can be on wired. If I have the connectivity, I have IPv4 and IPv6 home addresses. So the addition to that is route optimization. So I send back binding update to the correspondent node, right, saying my care of address is this. And if this node is capable of understanding the mobility stuff, he starts talking to me directly, right? And I also insert the routing header 2, type 2, in the packets. So if this guy is able to understand my care of address, they start talking directly to me. So, for example, if Ivan would like to call me on my home address, and he would have the same device as me, he would send packets back to Slovenia, right, to home agent. This home agent would send packets back to me here, and I would respond in the same way, but then Ivan would realize, hey, your care of address is this one, and we would start talking directly in the same network. Right? That's a route optimization stuff, and this is working. What we also do is flow mobility, so we can be connected to a different networks at the same time and send different flows to over different transports, right? So if one transport fails, all the flows goes over something else, and this is something that is working. This is something that from time to time I do a demo of that, showing the phone and do all the funky stuff. I run the web server on the phone, so you can connect from IPv6 internet to my phone, and then I change the network totally, and you're still able to ping my device and so on. So we said, okay, we have the prototypes, we have the running setup. Why not deploying this in a real environment, right? Okay, it's cool, me running around the world with a device that can do IP mobility. Yeah, okay, but let's use that for some purpose. And what we did was that I had an idea when I was discussing with one of my friends over a couple of beers. I had that vision saying, okay, we have mobility, it's cool. It opens up the green fields for application development and things like this. Why don't we deploy this stuff in emergency response teams? I mean, fire brigades, police, army. These guys that are first responders when there is a flood or fire or some catastrophe, they go out. Usually the connectivity is broken there, so they carry like 6-7 devices on their belt, on their neck, and try to communicate. Instead of saving lives and property, they try to communicate over Tetra, over wireless, over something, right? And we said, let's fix that. So we proposed that as a project when there was a call called GEN6. It's a European Commission project. They found half of it. And as a Slovenian proposal for the project was this IPv6 enabled self-organizing systems for emergency response environments. How does it look like? So we are now officially got the project, and we are going to deploy this actually. We have some partners. I'm from Go6 Institute. Laboratory for telecommunications is the leading partner. I now partially work for them. Just because of this project, we're working with the Ministry of Higher Education, Science and Technology. We have fire department, we have Cisco systems, and some wireless guys working with us. And what we will do is, I will show you the picture. What we will do is, we will install this mobility DSMIP6-TLS on the field. We will build a device for a fireman that he will carry around, connect to any possible transport, like wireless, like 3G, LTE, Tetra, wired system, whatever you like, satellite. If you can communicate over pigeons, I'm fine, right? I'm just fine with that. Just send the packets. And but the good thing is that this guy, this fireman, that will carry this device will be connected over anything, and we will create an overlay, mobile overlay, so this guy will be accessible on the same IPv4 and IPv6 address all the time. So guys, in a national emergency control center, we'll just connect to that IP, and they will connect directly to that device that is on the fireman. They will be able to engage the GPS, see the location of the fireman. For example, I don't know, the possibilities are really limitless. Now read the sensor, the temperature sensor on the coat of the fireman, and then you have a GPS position, you have a temperature, you create a heat map of the place. You see where is burning, where is the fire. You know, you can send video. You can call the guy over voice over IP. You have IP connectivity directly to that guy, and it is not changing for you, because it's an overlay. What's happening beneath, you basically don't care. It seems complex, but it's not, right? So this is the basic idea. We will try also with Tetra. I'm not sure that we will make it work, but we will try to bring it on. So these are the guys. This guy is the contact at the fire department. We will implement all that funky stuff into that device, and I think in a few months, I hope less than 1 year, we will have the demonstration for the European Commission, and we will have to show that our idea is really working on the field. So this is a bit of going into the details of how we want to interconnect all the stuff. We will probably use the vehicles as interconnecting and backup option. So the fireman connects with wireless to the vehicle, and at the same time over 3G with our national mobile operator. So they have different paths, and we will probably in the first stage install the satellite and Tetra communications in the vehicle, so the vehicle is near the situation. This will take a lot of work, but I hope that we will finally deploy something that will show how useful IPv6 in real life is, and how the mobile part of IPv6 really works. Yeah, these are the same stuff that I already told you. What we will do Slack and DHCPv6 stuff. We will do testing with proxy mobile IPv6 and network mobility, NEMO. So we will use network mobility for the vehicles. We will try the multicast stuff, the stuff that PP before was telling not to, right? Okay. For a few firemen. We will try to demonstrate how multicasting the video to multiple home addresses and devices with IPv6 mobility works, and we will try to emulate some quality of service. You know that having quality of service over a network that you even don't know to which network you are connected, it's pretty hard. But we will try to do that, and we will also try to demonstrate the flow label usability. I know that's controversial, but we will try to make it work. So that's it. If you have any questions, you can write me. There's my email, or you can find me around. For IPv6 in Tushmobil, Miha agreed that he will take all the emails and respond. For Mobitel, it's Primož, and for Simobil, it's Petra. If you have any questions, just fire them an email. And for everything else, it's me. So, thank you. Are there any questions?
The flow label, what actually you are planning to do with it? No, I have nothing to do with those people over there. That's an honest question.
Yes, I know. We will try to make the whole network flow aware. So when we will try to send some video streams, we will try to label them with the flow label and make the whole system flow aware. So they will treat packets differently. They will send them in the right sequence and so on. America?
Is there any vendor today that supports the flow label?
No idea.
I believe the answer is no.
Well, we don't know. We don't know. I haven't heard of any.
Is it supposed to be some kind of intermediate step between MPLS and routing?
No, actually, if the idea of flows was that the first packet, right, with the flow label, you get the triplet. You know, it's source destination, and flow label, and you create some special environment for this packet and all subsequent packets, right, that are following, to flow through the network. But these are illusions from ITF.
But it's still something similar to FEC, forward equivalent class or something like that in MPLS.
Yeah, I don't know. Well, honest answer is that we just started the project, this one, with GEN6, and we said, okay, we will try to figure out what to do with flows, with flow labels. We don't have yet the idea what we will try to do, but we will try to figure out something.
Somebody's going to find a solution how to use it one
well,
day.
you know, flow labels are there. Nobody's using them.
Yeah,
right.
The same like with I don't remember the TOS type of service in IPv4. Nobody used that.
Yeah, they are.
Then today it's DiffServ or
Yeah.
something like that. But before,
yeah, Pippi.
Actually, if you control both clients, and if they agree on what the flow label is and that they actually set it, then his home gateway could select, based on the flow label, the care of address of the mobile node.
some kind of additional security.
Well, no. If that guy is connected over a 3G network and a wireless network, then maybe the high priority but low bandwidth messages would go over the 3G network, whereas video stream
And
or
the
whatever
label will just say what's the RAT radio access type.
Yeah.
Ah, good.
But of course, you have to control both ends of the conversation.
Yeah. So actually, we are open for suggestions.
You just got one.
If you have any other suggestions how to use flow labels, come forward. I'm sure you will talk to me all the evening, so we can figure out something.
Are there any questions?
I'm standing between you and vodka.
So thank you very much for the presentation.
Thank you.